So we are going to learn about arrays, then the relationship between pointers and arrays, and how do we pass arrays to functions. We know how to pass a variable's value to a function. This time we are going to pass an array to a function. Now you must be wondering why I have started this list with a 0. So let me tell you that if you are a programmer, start counting from 0, not from 1. Programmers start counting from zeros. Anyways, let us start with this lecture. So let us start off with this. If someone commands you to store the age of 50 people, now to store something you will need variables, right? So store the age of 50 people. One way of doing this, one way of storing the age of 50 people, there are 50 values, right? So we will need 50 variables, right? We will need to declare 50 variables, age 2 and so on up until age 50, right? We need 50 variables, and to each one of them we will have to assign some values, right? And so on until 50. This is one way of doing this. But what if someone says store the age of 5,000 people, store the age of the whole population of your country? So that would be very difficult for us, right? We will have to declare 50 variables, or we will have to declare a lot of variables, and that would be a very tiring task. So to make things easier, C has arrays. So another way of doing this would be to use a single variable. A single variable which stores 50 values, right? Which stores 50 entries. And this single variable which stores multiple entries or multiple values is nothing but an array. Array, sometimes also called as a list, which actually an array is a list of entries, a list of elements, similar type of elements. So to summarize it up, an array is a variable that stores multiple values. And these values or these entries are of same type. So it can store multiple integers or multiple floats or multiple characters. It cannot store one integer and one float. So the values need to be same, need to be of similar type. Let us see how do we declare these arrays in the C language. Declaration. Firstly, it's very similar to how we declare a single variable. First you have the type, then you have the variable name, and in case of arrays you have to suffix the variable name with the size. So within square brackets, as many people know it, within brackets you have size. These brackets are square brackets. So if you want to declare an array which stores 50 integers, so you would declare it like int, and the variable's name is age and 50, the size. So this age variable, this array will store 50 integers. So it's a single variable, right? Okay, now this is how we declare a single variable, and this is how we declare an array. So what will happen when you declare an integer, declare a single variable? the compiler reserves some memory space and names it, and it will have some address and it will store some value. Now something similar happens to an array. Now you know that array, the number which is inside the brackets is nothing but size. Now according to this size, memory will be reserved. Now how will memory be reserved? It will, as the size is 5, it will reserve 5 blocks of memory. So this is 1 block, 2 blocks, 3 blocks, 4 blocks and 5 blocks. And regarding names, in this case we will have names like this. The first block will be named A0, second will be named A1, third will be named A2, fourth will be named A3, and fifth will be named A4. And this is called an index. The numbering of elements in an array is called an index, and it always starts from 0. So you have 5 elements, so if you start from 0, it will be 0, 1, 2, 3 and 4. So from 0 to 4 there are 5 elements. Okay. Now how do you assign a value to each one of these elements of an array? So if you want to assign the value 10, so you can easily guess now. We will do it like this. A of 0 of A is equals to 10. So 10 gets stored into the 0th element. A1 equals to, if I say 6, so 6 will be stored here, and so on. So we first declared an array and then we initialized it. We initialized its elements one by one. There is also another type of initialization as well as declaration. So another way of initializing and declaring is, you can say int a, and you can directly give values within curly braces. So we can directly give values 6, so this will assign 10 to the 0th element, 6 to the first element, 1, 8 and 7. This way elements will be assigned when the array is declared. This is one way of doing this. This is another. Now when you initialize and declare, this is not necessary. When initializing while declaring. Okay, now let us write a program involving arrays. So what we are going to do in this program is very easy. We are going to take input from the user and displaying the same input. So first of all, we will declare an integer array. So int, let's name this array as ARR, and the size is 5. So integer array of 5 elements, right? Now we will have to loop for 5 times to scan the input, because to scan 5 inputs we have to ask the user for 5 times. We will need 5 scanfs. So instead of 5 scanfs, we will have only one scanf, and we will repeat the same scanf for 5 times. So we will need a for loop. For I is equal to 0, because an array always starts from 0, so we will use I also as 0. For I is equal to 0 and I is less than or equal to 4, because the array is up to 4. From 0 to 4 there are 5 elements, and we want to increment it one by one. Oops, we haven't declared the integer I, so we will declare this integer I, which is nothing but an index variable. We will call this an index variable because we are indexing the elements of an array with the help of I. Now we are asking for the user input. Printf enter a number. Right. So the user will enter a number after this. So we have to scan that number, scanf, and that is an integer, so %d, and it will need an address. So address of A of I. Right. Now how this will work is very simple. The control will first ask the user to enter a number. When the user will enter the number, for the first time this loop runs, I's value is 0. So it will store the number in A0. Next time the loop will run, it will store in A1. So this way it will go on storing A0, 1, 2, 3, 4, and the fifth time the loop runs, it will not run because of this condition. Okay, so we have our input ready. Now we are going to print the output. Printf \n, so that we go into the next line. You have entered these numbers. So again we will need a for loop. We will need a loop to print 5 numbers. So for I is equal to 0, again I is less than equal to 4, and incrementing by 1 each time. So thus the loop is going to run for 5 times. So we are going to printf an integer, and this integer is going to be each element of array. So I. We are indexing the array with the help of variable I. So this is our program. Let's run it and check it. So it is showing an error. What the error is, A undeclared identifier, and the line number is 11. So in line number 11 we have done a spelling mistake. We have committed a spelling mistake here. There is no such variable A in our program. We have ARR. So let us correct this error and see if this runs or not. So it is asking for a number. So enter any number, 5, 7, 10. You see it is running in a loop, 9, 1. So this is the last time we will enter because we have completed 4 loops here, and this is the 5th loop, and it is displaying the output correctly, 5, 7, 10, 9 and 1. So this is how you use arrays in your programs. Now this was a very simple program, but believe me, you can do a lot of things with arrays. And one of the amazing things or amazing operations you can perform on an array is to search an array. So let us say we have this array and the numbering starts from 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 10 elements, right? 0 to 9 we have 10 elements, and let us say we have to search the number 5. We have to see to it that is there any number 5 present in this array. So how can we do this? We can compare 5 with each of the elements to see if they are equal or not. So we can compare 5 with 2, 5 with 6, 5 with 1, 5 with 9, 5 with 5, and at this point it succeeds. So our output should be at position 4, right? Position 4. Now this way of searching, this way of comparing the input element with each of the elements of the array is, and this method is called as linear search. So we are searching the array linearly, starting from the 0th element and going on comparing with successive elements until we reach the last element. If found, we show the output. If not found, we say that we cannot find the element. So let us actually write a program for this. So we have included standard input output header. We have the function void main, and let's declare the array arr. You can have any name. For simplicity, I am naming this as arr equals to. Now this time I am not specifying any dimension of that array, any size of the array, because I am going to directly initialize this array here. So 2, 6, we have 10 elements here. So 1, 9, 5, 10, 25. What else do we have? 16, 19 and 12. So we have initialized our array. So while you initialize and declare, the dimension or the size of the array gets updated automatically. So let us ask the user to enter the number to be searched. Printf searched, and let us scan that input. Scanf, scanning an integer, so %d, and we will need a variable. So let us declare an integer n, the number to be searched, right? So address of n. Okay, now we have our input, that is the number to be searched. Now we will need a loop to constantly go and scan, to constantly go and compare our number with each of the elements of the array. So you can guess that how many times this loop will be running is 10 times, because 0 to 9, to loop from 0 to 9, you will need to run the loop for 10 times. So let us declare another index variable. So I, let us call that variable as I, and use this in the for loop. For I is equal to 0 until I is less than equals to 9, until I reaches 9, and the method of incrementing is to increment by 1. So I plus plus. Right. Now we are checking if the number n is equal to the current element of the array. So if n is equals to the element of the array, current element arri, if it is true, we are going to run the if block, and inside the if block we are printing that yes, the number is found at this position. So this number, that is %d, is found at this position, that is %d position. So the first %d is for the number to be searched, so n goes here, and the second %d is for the position. So the position is actually the I, right? And when we print the output, we will return, right? We will exit this program after we print the output. After we find our solution, after we find the number, we are going to exit the program. So let us return from this point. So, but if we cannot find the number, the loop will run for 10 times, right? It will cross the upper limit of the array when i's value will be equal to 9, right? So this means that the control will come out of this loop. So if the control cannot find a number, we print that the number cannot be found in the array, right? And no need of returning, because this is the last statement of our program and we are not returning, we are returning void from the main function. So let us run this program and check if this works or not. So let us enter the number to be searched, 5, and it says that 5 is found at 4th position. So 0, 1, 2, 3 and 4. Let us run this program again and this time enter an output, enter a number which is not in the array. Let us enter 50, which is not in the array. So it says that number cannot be found in the array. So this way you can do very awesome and very interesting things with arrays. So now comes an important topic. We have learned about pointers before. A pointer is nothing but a variable which stores the address of another variable. The pointers are quite related to arrays also. Arrays also have address. Let us put it this way. When you declare a variable, memory is reserved, it is assigned some value, it is assigned a name, and any memory location has an address. Now what happens when you declare and define an array? So let us assume that you have declared an array of 4 elements. So 4 memory spaces will be reserved. The reason I am drawing these 4 boxes side by side, because memory is assigned continuously. So let us assume that you have also named the array A. So this is the 0th element, this is the first element, this is the second, and this is the third. A0, A1, A2, A3. These are the names of each of the elements of the array. Now each one of them have some values, so let us randomly put some values in them. 15. Okay, and each element or each memory space reserved for the array is for each of the elements of the array contains an address. Has an address. So let's assume that the first element A0 has an address 100. So you can guess that the next element will have an address 104. I said that memory is allocated continuously. First element, then the second element, then the third element, then the fourth element. It is assigned continuously. So this would be 108 and this would be 112. So actually there is a difference of 4 between each of the addresses, because first element occupies 4 bytes, then the second element occupies 4 bytes, and so on. Now why 4 bytes? Why plus 4? This depends upon the size of an integer. Now 4 is the size of integer in 32-bit environments like the Visual C++. If you use Turbo C, this will be plus 2. And we have also seen this before. Okay, now what will happen if I printf, let me write it, printf %d and address of a of 0. What will happen if I do this? Address of a of 0. A of 0 is this memory cell, and the address of a of 0 is nothing but an integer. So %d, we are printing the address of the first element of an array. So we can guess that this output will be 100, and this is absolutely correct. Now imagine if I write printf same %d, and this time I write only a. I write the name of an array, name of the array. So this will also output 100. We have just written the name of the array. Now you can infer from this, what I have written is, you can easily guess or easily infer that writing the name of an array gives base address. Base address means address of the first element. First means base, 0. So array name gives the base address. Okay. Now some more interesting stuff here. What if I do star of a, value of a? Now a gives me the base address. Base address is 100 and value at 100 is 10. Right. What if I do star of a plus 1 within parentheses? So a plus 1, a gives base address, so star of 100 is the base address plus 1. Now we have studied pointer arithmetic in our previous lectures. So when I increment an integer pointer by 1, so it will be incremented by the size of that integer. So this will be 100 plus 1 will give me 104, right? The pointer to the next integer. So plus 1 means next integer, plus 2 means next of next integer. So this will give me 104, and the value of at 104 is 5. Similarly, if I do star of a plus 2, let's put it 3, so it will give me this address. Value at the address 112 is 15. So this is how you access arrays using pointers, and using pointers is one of the most interesting and cool way of accessing the value of an address, of an array, I mean. Okay, we have studied functions in our previous lectures. We know how to pass arguments, how to pass parameters to functions. We can pass single variables to functions. These are called arguments. Now how do we pass the data contained in arrays to some function? So let us say that we have declared an integer array A of 10 elements. Now how do we pass these 10 elements to some function print array? Let us say we have a function that will print these 10 elements. How do we pass? There are actually two methods. We can pass each value one by one. So we can run a loop which will run 10 times, and we can pass the elements, the values of the array. We can pass each one of them one by one. So the function call would be made 10 times. Or we have studied pointers just before. We can pass the base address. So we will have to just pass the base address and collect that into a pointer in our function, and using that pointer we can easily access the value of our arrays, of the elements stored in our array. So let us first see how do we do this. How do we pass each time? How do we pass each value one by one? So we can have a for loop from I is equal to 0 to I is less than 10, means I is less than or equal to 9, and plus plus. And the name of our function was print array. So print array, then we can pass I of A. So the print array function will be called 10 times, and each time it is called, the new element of array, each element of array gets passed to this function print array. And let's see how do we pass using this method. Pass the base address, and it's so simple. In this method we call the print array function, and we just pass the base address, right? We just pass A. Now passing the base address is not enough. The function, the control will jump to our function, so it cannot access the upper limit of this array, the maximum size of this array. It does not know the size of this array, so we will also have to pass the size of this array along with the base address. So 10 is the size of this array, so we can pass this 10, this size and the base address to the function print array. So let us see how do we pass these values, pass an array to a function, and let us write a program for that. So as usual, including the standard input output header. After that, our main function. Now we have the array int arr, the size, let's say we have defined it as 5. Let's initialize it here only. So the size we have initialized to 5, and let's put some elements in this array. Second element, the third element, 6, 9. Let's say we have this much of elements here, and call a function print array, and we will pass the base address. So just say the name of the array, and we are going to pass the upper limit, that is the size of the array. Now this arr is the base address. We know this. Now we are calling the print array functions, but we have not declared this print array function. This print array function will return nothing, so void print array, and it is going to receive an address, and any address is to be stored in a pointer variable. So we are going to store it in a pointer variable. Now this address is an address of an integer, so we will collect it in an integer pointer. So int star, and the second argument 5 is an integer, so this is an int, a semicolon, so that we declare this array. Let us define this array now. Void print array int star. So let us collect this arr variable's value, that is the base address of this array, in a variable, in a pointer variable, integer pointer variable a, and this 5 is collected in the variable size. So let us make use of these two variables and print the array. So printing the array will require an index variable. So int I will be our index variable. For I goes from 0 to I is less than size. Now size is 5, but the loop will run from 0 to 4. That's why I have put a less than sign. So I is less than 5. Now, I is less than 5 means I is 4, up to 4. And increment method is by +1. Printing an array we know is very simple. Run a loop and print the value of each element one by one. And now here comes the most important point. Now how do we access the value of a pointer? Now we have the base address. We have to print the value of each of the element. So the first element will be accessed by star of a as value of a. Now the second element will be accessed by value of a plus 1. Now the third will be value of a plus 2. So actually we have this 0, 1, 2, 3 recurring. We are incrementing this. So the index variable is coming to our rescue here. So value of a plus I. And here we go. Our program has been done. Let us execute it, and it has printed the values of our array. Now what happened is, for the first time this for loop runs, I is 0. So %d value of a plus 0, that is the base address, plus 0, that is actually the base address, value of base address, which is 10. Now the second time this loop runs, when the value of I is 1, value of a plus 1, base address plus 1, that is the first element. 2 means second element. So this way the output is printed.